In this question, you are required to find the two unknown tensions in the string FA and FB. Now, before we solve this question, let's go through some basic concept. This is a uniform plank, 6 meter, and is 20 kg. Because it's uniform, the CG will be exactly at the center. That means it's 3 meter away from the both ends. So you're required to draw the weight on your own. You will draw the weight from the CG, and this will be 200 Newton. Next, because this plank is in equilibrium, at rest, suspended in the air, there are actually two conditions that you must know. First one being principle of moment. You can apply it here. The sum of anti-clockwise moment equals to sum of clockwise moment. And secondly, because it's at rest, suspended in the air, according to Newton's first law, all the forces are balanced and the net force acting on the plank has to be 0 Newton. As for this question, all the forces are either upwards or downwards, so I can say that total upward forces must be equals to total downward forces. And for this case, FA and FB, they are my upward forces. They have to be equal to my downward forces of 600, the weight of the person, plus the weight of the wooden plank. So FA plus FB will be equals to 800 Newton. Now, for this, right now, the man is nearer to A. You should know that FA, the tension in FA, has to be greater than in FB. So these are things that you must know so that later on when you get your answer, you can roughly check. So when will FA equals to FB? If this man were to shift to the right and he's standing exactly at the center, then the total load of 800 Newton will be shared equally between FA and FB. So these are the various things that you must know before you start the question. In this question, you are not given a physical pivot point, but because this plank is in equilibrium, you are basically free to take any point as the pivot. You can take the center, you can take a point A, point B, or the extreme end of the plank. But to work smart, because I need to find the unknown FA and FB, I have two unknowns here. So obviously, to make it easier for me, let's find one of them, and obviously I will take my pivot about point A. Why? Because this FA is still there, is unknown, but the line of action of FA passes through the pivot point, so there's no perpendicular distance from FA to the pivot, so FA will not create any moment and it will not be included in my principle of moment equation later on. So let's start solving this, taking A as the pivot. So I apply total anti-clockwise moment equals to the clockwise moment. So right now, this FB is creating an anti-clockwise moment. So that's FB. And the distance from FB all the way to the pivot, you know, is 4 meters here, because the whole thing is 6 meters. The two ends here is 1 meter. So FB times 4, that's all for anti-clockwise. For clockwise, there are two, the weight of the person plus the weight of the wooden plank, both contributing to clockwise movement. Let's start with the weight of the person, 600 times 1 meter, plus, because it's a sum of clockwise movement, 200 times from here to the pivot is 2 meters. So if you solve for your FB, the answer will be 250 Newton. Now, how do you solve for FA? You can actually do the same again, but now taking B as a pivot. But if you do that, that will actually take a lot of time. And in the previous video, I've told you you can actually apply your Newton's first law. So total upward force, which is your FA plus FB, must be equals to the total downward force, 600 plus 200. So FA is what you want to find, and FB you already found previously, which is 250 is equals to 800. So FA will be 550 Newton, which is bigger than FB. So you roughly know that you are on the right track. Let's say you have time to check, you can actually take pivot about point B to find FA. So let's take pivot, okay, at B. So total anti-clockwise moment equals to the sum of clockwise moment. So in this case right now, FA will be creating a clockwise moment. So FA times the distance from FA to the pivot will still be 4 meters. And now the weight of the man, 600, will be creating a anti-clockwise moment. So from the weight of the person all the way to the pivot B, that will be 3 meters here, plus the weight of the wooden plank times 2 meter to the pivot B. So if you solve here, you will get back the same answer, 550 Newton. So how do you double check whether your answer is correct? You just take 550 plus the 250, total must give you 800 Newton. So that's how you solve this question. In this last part of the question, you are required to find the maximum unknown distance D in which the man can walk to the left of point A before the thing topples. So initially it seems like a difficult question, but if you think about it, it's actually very simple. When this plank is about to topple, you should know that the string here will no longer be in tension. It's like sagging here. So the tension here will basically be 0. So in other words, this is totally useless. So this suddenly becomes a very simple single pivot question. And this weight of the man will now create an anti-clockwise moment about point A. And the weight of the wooden plank will now create a clockwise moment about point A. So you applying principle of moment, anti-clockwise moment is equals to the clockwise moment. The anti-clockwise moment will be the weight of the person times the unknown distance, and the clockwise moment will be the weight of the plank times the perpendicular distance from the line of force to the pivot, and this will be 2 meters. So if you solve it, the maximum distance he can move will be 0.67 meters. So that's how you solve this question.